Alright, next up we're going to take a look. We're still going to look at this cotangent graph that we looked at for phase shift, but we're going to be asking a different question. So here is our transformed cotangent function. What else can we determine based on just the graph alone? So the question we're going to ask now is, what is the vertical shift of g of x? Now, when I ask what is the vertical shift, I'm asking from the parent function. So I'll go ahead and put that part in the question. So, well, in order to know that, we need to graph the parent on top of the original. So that's what we're going to do for step one, just like we did with phase shift. Graph the parent function on top of the transformed function. So again, you need to know the parent graph for cotangent of x. Here it is. It's a bunch of S-curves like this that alternate. There's got some asymptotes here. Here's our transformed graph. It's got a little bit different of an S-curve. Looks like, so it's probably been maybe stretched or shrunk. But the question here is asking, what is the vertical shift? So here's what you might be thinking, well, doesn't the vertical stretch or shrink matter? Well, it does, but check this out. Look at this point on our parent function. What's the y value? It's 0, right? So even if you were to multiply by a number, it's going to remain 0. That means the only thing that could change is the vertical shift from that point. So here's what we're going to do. We're going to locate an identifiable point on the parent function, and you need to pick one that's at 0, right? So this is perfect at negative pi over 2 comma 0. Step 3, you're going to pick the twin point on the transformed graph. So notice that this point as well is at the middle of the S, just like here. So that's going to be my twin point, negative pi over 4 comma 3 for my transformed function. And to get the vertical shift, you're going to take your second y value and subtract your first y value. So let's see what those are. Second y value is 3. The first one is 0. So 3 minus 0 is 3, and therefore this tells us that the transformed function, the red one, shifted 3 units up from the parent function. That's it for this video. If you have any other questions about it, let me know.